Hello.
Hello.
Good morning, class.
Morning, Doctor.
Morning, Doctor.
Morning, Doctor.
Morning, Doctor.
Right. So for
Morning, Doctor.
test 2, it will be on 4th June. Another 2 weeks. Okay. So for test 2, only BJT chapter will be question. Okay. And then for our today class, can you see the 2 circuits on my slide?
Yes.
Effect of capacitors on frequency response.
Yes, Doctor, I can see the circuit.
Okay, so from previous class, we have learned how to, from DC analysis to mid-frequency analysis, okay, for the circuit, right? Okay, so for today, we're going to continue how to do analysis at low frequency and high frequency. All right, so firstly, for your during mid-frequency analysis, okay, during mid-frequency analysis, what you did is to open circuit all your capacitors, right? And now we're going to learn how the capacitors give effect for our circuit, right? So the capacitors will affect during low frequency and during high frequencies. All right. So firstly is at during low frequency, the effect is caused by the capacitors at the circuit. So usually we have a capacitor at the input and at the output. Okay. This is the coupling capacitor. And then we have a capacitor at emitter part. Okay, this is a parallel emitter capacitor. Okay, so this is to bypass the RE, okay, resistor RE. So what happened is that when we do bypass capacitor over here is to stabilize the circuit. So let's say, for example, if we don't have a capacitor over here, okay, during mid frequency response, what happened to our signal is we cannot get a stable during mid frequency analysis, okay, because we have the RE here. Okay, so during mid frequency analysis, what happened to the capacitor is short, right? We short circuit it on our simplified circuit. But if we don't have CE at RE, okay, so during our mid frequency analysis, we need to draw the RE. So when we draw RE, okay, you see that the current that coming from the collector to emitter will be divided. So the V out will also be affected, right? But when we have CE bypass RE, okay, your emitter terminal for the BJT is short circuit to the ground. Okay, so your current flow from the collector to emitter is same. IC and IE will be the same because there is no resistance at the emitter part. That's why we need to have a bypass capacitor at the emitter part, so that our output will be larger compared if we don't have any capacitor at the RE. Okay, so now we want to do the analysis at low frequency and also high frequency. Okay, so everyone have this circuit, right? Okay, can you see my circuit over here?
Yes.
Yes. Yes. Minum dulu tes.
Okay, take your pencil and calculator. We need to draw C1, C2, and also CE, okay, for the circuit. So what happened is that, firstly is draw the hybrid pi model for this circuit. Okay, so here the VCC, okay, the VCC here, because now we are analyzing the AC circuit, so we only need VS. Okay, so let's draw the BJT into a hybrid pi model. So we have, here is the input is at the base, and then the output is at the collector. Alright, the emitter is over here. So we draw the input and output node, and there is another one is emitter. Okay. So from base to emitter we have pi. From collector to emitter we have current. This is NPN, so the arrow is from C to E. Here is R pi. Don't forget to label the V pi and R pi. So here at the base, you can see there is two resistor, R1 and R2. During AC analysis, you need to, the VCC or the DC source, you need to ground it, right? So here at the base, you have R1 and R2. Okay, so from the previous class, R1 and R2, we have already calculated as what? RTH, right?
Yes.
And then from the base, you have C1. Okay, you need to draw C1. And then you have RS and also VS. At base, you have VI. VI and ZI is, we only need it during mid-frequency analysis. So during, when we do low-frequency analysis and high-frequency analysis, we do the VI, ZI, Z out, it doesn't matter for us, all right? And now at the collector, you have a capacitor C2 and also a resistor RL. And then at the emitter, you have RE and CE. So you just draw the RE and also alright, so now we have three capacitors that we need to do the analysis. Okay. So firstly we take the effect for C1. Okay, so what we can do is actually from the capacitor, we can determine the frequency that affected by the capacitor. So for RC is over here. Okay, any component I have missed?
No, just RC.
Okay. So when we want to do analysis for the C1, what we need to do are the capacitors. When we want to do analysis at C1, okay, other capacitor we need to short circuit. Okay. So first, we do analysis at C1. When we do analysis at C1, other capacitors, C2 and what is this? CE. We put it as short circuit. And then we have GMV pi over here. GMV pi, we put it as open circuit. Because we didn't take it into our analysis. So we redraw the circuit C1 and okay, so try to redraw the circuit. C2 and CE, we put it as short circuit. GMV pi, we put it as open circuit. So here we have C1, RS, another one. VS, RS, C1. So C1 have RTH over here. RTH, R pi still over there. And then RE. Okay, CE is short circuit. GMV pi is open circuit. And then C2 is short circuit. RC is over here. And CRL. Okay, so RE is. So what happened to RE in this case?
Okay.
Okay, RE shorted, right? So that's mean here what you can see is okay, only RTH, R pi, and also RS, okay, will be considered into our analysis, right? RC and RL we didn't care because the circuit over here is already disconnected. Okay? Okay ke everyone?
Oh, okay, Doctor.
Okay, so I simplified it over here. C1, RS. So here RTH. Okay, so the circuit is simplified as this green color. Okay, so here for the capacitor, okay, we want to determine the frequency that affected by the capacitor. So we have the frequency equation, okay, F equals to 1 over 2 pi RCA. Okay, so this is the R resistor. We need to consider all these three resistors. These two resistors are parallel. RTH parallel with R pi. Is capacitor means short circuit to both medium frequency and low frequency analysis? Okay. For medium frequency, we put it as all of the capacitors are short circuit. But during low frequency, we didn't put the capacitor into short circuit. Okay. If you see here, I still draw the C1, C2, and CE. Okay, so this is the low frequency hybrid pi model. Okay, if you are drawing the hybrid pi model for mid frequency, you put the C1, C2, and CE as short circuit. Okay, so if you draw it as short, this is for mid frequency hybrid pi model. Okay, don't get confused. Okay, we are now doing the low frequency analysis. Okay, so for C1, we will have F1. So F1 will be equals to 1 over 2 pi. Okay, the resistor here is Rs. Okay, Rs and RTH R pi is series. Okay, but RTH and R pi here is parallel. So here is, you rearrange the equation, or no, you rewrite the equation as Rs series. So you plus with RTH parallel with R pi. And then you multiply with the capacitor is C1. Okay, so this is F1. This is F1, so you get how much is the frequency value. And then you need to do the same analysis, okay, for another two capacitors. Okay, so number 2, C, which one is simple? Okay, we use C2. When you want to analyze for, C2. C2, you put C1 and CE as short circuit, GMV pi as open circuit. Okay, so you need to redraw the from the blue circuit over here. Okay, you need to simplify it to get the frequency that caused by C2. Okay, so I want to simplify C2 is over here. CE and C1 are short circuit. So we have RS and VS. C1 short circuit. Still RTH over here. And then have R pi. CE is short circuit. GMV pi. Okay, C2 and RL. So here you can see that the circuit is disconnected. Disconnected at GMV pi. Okay. So for C2, okay, the circuit is very simple. You only have RC and RL, right? So F2 will be 1 over 2 pi. RC and RL are series or parallel.
Series.
Okay, so series you need to,
Sum it up.
all right, RC plus RL. Don't forget to multiply with C2, right? Okay, now we have another one. Another one capacitor is CE. So for this one, for CE, C1 is short circuit. Okay, now I want to draw it over here. C1 short circuit, C2 also short circuit. But here you have GMV pi is open circuit. So number 3 is CE. So I draw it on top of the page. You have RS and BS. C1 is short circuit, and then you have RTH, and then R pi, RE. Here you have CE. Okay, so GMV pi is open circuit. Okay, so I don't want to draw lah. Here is R pi. Here it is RE. This is RTH. Okay, everyone.
Yeah,
So
okay.
here you can see the CE. Okay, you have 4 resistors over here. Right. So here for RS and RTH, okay, these are parallel. Okay, parallel, right? So this parallel, and then you have R pi over here. Okay, if you still remember when we do the mid frequency analysis, the current that flow through RE are not the same with R pi and RE are different, because here is IB and here is IE. Okay, IB is very small compared to IE. So you need to find equivalent resistor, or by using the current, by the same current, you need to define what is the exact resistance that caused by the R pi. So here I redraw. This is RS and RTH. And then you have R pi and RE. This is RS parallel with RTH. Okay. So now you need to determine what is the equivalent resistance by RE. R pi. Okay, so this one we can use the equation from the previous note, right? So here, if you still remember, I label it as a small e lah. Okay, small e equals to this resistance. Okay, this is RS parallel with RTH. I label as R total. Okay, so here RE will be equivalent to beta plus R pi divide with beta plus 1. Okay, so this will be the equivalent resistance over R pi over here. Then what happened is, okay, we need to redraw it. So here we have resistance, here RE. So these two also parallel. So our frequency E will be equals to 1 over 2 pi. The resistor is RE parallel with
Excuse me,
Dia nampak tak?
can you explain again about the R pi RE equal to beta R pi?
I add another then I add another page. So we redraw for CE. Yeah, for CE, yeah. So we have RS, C1 is short circuit, and then we have TH, and then we have here CE. Okay, so first is we need to find the equivalent resistance for R pi. Okay, so here is R E. Okay, so this is S. This is short. So here is R T. Okay, so we simplify the circuit, it will be R T by RE. So here is RE is equivalent to RT. This is series. RT plus R pi divide with beta plus 1. Okay. What happened to my slide? So FE is equals to 1 over 2 pi RE. RE here is parallel with RE multiply with CE. Wait, I check. RS short T, RT and R pi series. So we divide with beta plus 1. Yes, this one. Okay, this one. We can refer to mid frequency slide. Mid frequency analysis. These two is series. This the current is same. Same. Okay. But over here, over RE, over here the current, the I is bigger. RT equals to RS parallel with RTH. Oh, okay. So here RT is, if you do KCL over here, because if you are confused why it's like this, okay. So RS, here is the current. I label is as I1, I2, here is I3. Okay. So if we do KCL, we know that I1 equals to I3 plus I2, right? But here our I3 is equals to IB. IB is micro ampere. Okay, so this is very, very small, which we can assume that I1 is equals to I2 because IB is very, very small, micro amp. Okay, that's why RS and RTH here we can make it parallel. All right. However, the R pi, the current that flow through R pi is different. That's why here we need to consider the beta plus one value. Okay. All right. So that's it. Try to put the value for F1, F2, and also FE. So F1, if I press my calculator correctly, F1 would be, F1 is, how much F1? Around 16 Hertz. F2 would be around 0.65 Hertz. FE 594 Hertz. Okay, your friend asked me why RS is not series with RTH. Okay, so this is the same node. Okay, you cannot say RS is series with RTH. If you say RS is series, okay, it's supposed to be RS over here and then RTH over here. Here is R pi. Okay, this is series. Okay, this is series. But our circuit is, it's not like this. Okay, our circuit is, the orientation is like this. So this is parallel. Okay, can you get your frequencies?
No, because there is no values for beta or R pi.
Oh, beta R pi, you can use the same as previous. Beta is 80.
80. Oh,
Yeah, because this is from previous DC analysis. Beta is 80. And another one, what is this?
just beta.
Right. Okay, so here you have, actually from these three, okay, these three frequencies value, you can draw a board plot, right? But we cannot do board plot in this online class. Take into consideration for your frequency response, okay? Previously, you do the mid-frequency analysis where you get almost fixed or constant gain, AV, okay, almost constant gain. But then you also have the effect of the capacitors that you use in the circuit, which couldn't provide you fixed gain, or the gains will be varies. So here, what happened to this frequency? Okay, so for low frequency analysis, the highest frequencies, okay, here if you draw F1, F2, F3, the smallest will be F2, and then F1, Fe, right? F1 over here, and then F2, and then Fe. So Fe is the nearest to the gain, or the during near to the mid-frequency analysis. So here, you can take in consideration only Fe, okay, to roughly draw your board plot. You just take, so here, before the frequency get the fully charged, okay, it will give you a various of frequencies. So here is caused by the during low frequency, okay, low frequency. So we can only consider our Fe because Fe is the highest. Okay, so it is near to the mid frequency. Okay, and then here is the high frequency.